Welcome. Now we will discuss maxima and minima of a function. From the name itself, it shows that when the value of a function will become maximum or minimum, this is our interest to know. Let us first draw a graph that will help you. Let us assume it is a randomly drawn graph of fx. Before entering into maxima and minima, one thing I want to clarify: what is meant by dy dx? dy dx is actually rate of change of y with respect to x. As in straight line we have done that n equals to y2 minus y1 by x2 minus x1. That is the rate of change of y with respect to x, and that was denoted by tan theta. Similarly, suppose if we are interested to know the dy dx at this point, you have to draw a tangent at this point. And this theta is an acute angle, and since it is an acute angle, it represents that the tan theta is positive. Tan theta positive means the function is increasing. Rate of change of y is with respect to x, that is y increases as x increases. Here, if we are drawing the dy dx here, again we will get a theta where tan theta integrate. Again here also it is, we can say that tan theta 2 is positive. It is acute angle, so tan theta is positive. So dy dx is positive. Again it indicates that the function is increasing. And if we are plotting at this point, you will find that this here theta, this angle is an obtuse angle. Don't forget to take that theta when we are taking tan theta, that is with the positive direction of x-axis. So here theta is an obtuse angle. That means tan theta is negative. It indicates dy dx is negative, and dy dx negative means the function decreases as x increases. Now, so here what we are observing, the function was increasing. Here also we are observing function was increasing. Here we are observing the function is decreasing. That in between these 2 points, some serious change occurs. A function was increasing, now it is decreasing. So what we can say, usually it is observed that something is increasing to decreasing. That means change is not taking place all on a sudden. Change is taking place slowly. So between somewhere there will be a point. If we are drawing dy, the tangent will be like this, and here it will never meet x-axis. So theta is 0 and tan theta is 0, which indicates dy dx is 0. That means there is no rate of change for a particular point. This point is known as turning point. Similarly, if you are observing here that the Okay, drawing once again. Here you can see theta is obtuse angle. That means the function is decreasing. And here if you are plotting, here you will find theta is acute angle. That means the function is increasing. That means here again the function converted from decreasing to increasing function. The function converted from decreasing to increasing function. Here also some serious change takes place, and we will find in between some point where it will be parallel to tangent will be parallel to x-axis. That means theta is 0 and tan theta is 0. That means dy dx is 0 and rate of change is 0. There is no rate of change. So in this way, there will be certain points where dy dx is 0. In these points we can say, these points are generally known as critical points or turning points. There is a turning takes place in a function. So from the figure it is evident that this is the maximum value and this is the minimum value. Similarly here you will get a maximum value. Here again you will get a minimum value. In this way, in a function there may be more than one maximum values and maybe more than one minimum values. So that's why these minimum value or maximum values are not known in absolute terms. These are called local minima or local maxima. What is meant by local minima or local maxima? When we are saying this point is maximum, that means it is maximum in its very close neighborhood. This is minimum, that means this is minimum in its very close neighborhood. Let us take an example. Let us assume one of our student Jisha. If she is saying that her maximum marks she obtained in maths is never more than 70. It may happen. But sometimes she may have got much more marks than this one. She has forgotten it. In this means in its close neighborhood, that means in recent time her maximum marks is 70. But in some other time her maximum marks may be more than that. And one more interesting thing is here. See, this is the maximum marks and this is the minimum marks. These minimum marks may be greater than maximum marks. Here it is possible that a minimum marks may be greater than maximum mark. That means in its close neighborhood, this is minimum, but it may be greater than this maximum value. So maximum value may be greater than minimum value, and conversely a minimum value may be greater than maximum value. So from these graphs we can observe easily that which one is maximum, which one is minimum. But think it is practically always not possible to plot the graph of a function. There may be various difficult type of graphs, functions whose graph it is very difficult to draw and it may not be possible always. So now we require an alternative method. What is that alternative method? So again I will repeat one thing before entering into that alternative method. Here when the function is converting to increasing to decreasing, there a maximum marks will be there. When a function is converting from decreasing to increasing, there will be a minimum value. When a function converting from increasing to decreasing, there will be a maximum value. When function converting from decreasing to increasing, there will be a minimum value. And maximum value and minimum value or maxima or minima come alternatively. There cannot be two consecutive maximas. There cannot be two consecutive minimas. Maximas and minimas are coming alternatively. So, can we find an alternative method for it? So, for finding, I would suggest you a particular method. Try to follow that method. Then, if you can follow that method properly, it is very easy to calculate maxima or minima. First find, suppose y is given something. Something is given. First find dy dx. After finding dy dx, find d2y dx square. Then say at turning points dy dx equals to 0. So put the value of dy dx, whatever you got, that one equals to 0, and solve for different values of x. Find different values of x, maybe x1, x2, x3, etc. Okay, different values of x when dy dx equals to 0. After finding this one, put those values x1, x2, x3 at d2y dx square. That means find d2y dx square at x equals to x1. Then similarly find at x equals to x2, at x equals to x3, where see d2y dx square, there are three possibility may come. d2y dx square may be greater than 0, d2y dx square may be less than 0, d2y dx square may be equals to 0. d2y dx square greater than 0 for any of these values, that indicates that one gives you minima. If d2y dx square is less than 0, this will provide you maxima. Means this value of x, for which value of x d2y dx square is greater than 0, that value of x, if we are putting in y, you will get the minimum value of y. And if we d2y dx square less than 0, for what value of x, that value if we are putting in y, you will get maximum value of y. The third possibility is there, d2y dx square equals to 0. This is known as point of inflection. It is neither minima nor maxima. So again, remember, for finding maxima or minima, first find dy dx, then find d2y dx square, then say at turning points dy dx equals to 0. By solving the putting the values of dy dx equals to 0, you will get different values of x, maybe one or more values of x. At those values of x, find the value of d2y dx square. If it is coming greater than 0, that value of x will give you the minimum value of y. If d2y dx square is less than 0, then that value of x will give the maximum value of y. But if d2y dx square equals to 0, it will not give you maxima or minima. Before concluding, once again I will remind you that a maximum value may be less than a minimum value, and the minimum value may be greater than a maximum value. Thank you.